Hello, welcome back. So today let's talk about TypeScript. We'll be introducing TypeScript and also we'll be taking a look at different types, data types that we have in TypeScript. But basically we'll be diving deep beyond basics. So this class might be long, but we just have to watch it with patience. So TypeScript is not just types, okay? When we always say, if you're writing TypeScript, your JavaScript has to, we are adding more types to your JavaScript, okay? TypeScript is not just for types, okay? For most beginners, they think TypeScript is just adding types to JavaScript. No, it's beyond that. They also think that is incomplete. Okay, that's very, very incomplete. TypeScript is not just adding types to JavaScript. There is more to TypeScript. TypeScript is actually a type system. If you have written code in C Sharp or C++ or Java, you know that everything has to do with type. Okay, the static typing in those programming languages. Now, this is what JavaScript lack. So TypeScript actually helps JavaScript to do that. So TypeScript is actually a subset of JavaScript. So anything you can do with JavaScript, you can do it with TypeScript. So every JavaScript file is actually a valid TypeScript file too. So it is a compiler, it is a type system, it is a compiler, it is a developer experience tool. All right, because with TypeScript, developers experience is actually amazing because of all those early error bug catching. Okay, so it's also a code quality enforcer. When you're writing in TypeScript, right, your code has more quality. It enforces you to write a very big high code quality. Okay, and it is built by Microsoft. It is designed to help you build large-scale applications. So from now on, you should be writing everything in your JavaScript. You should be writing TypeScript from now on. This is exactly what big companies are actually looking for. So let's take a look at TypeScript as a compiler. It's very, very important. So the TypeScript compiler, we call it TSC. TXC does three major jobs. First of all, it checks your type, it checks type checking. So, but before we continue, all right, let me open this. I have a folder I call TypeScript, and everything is there. So what I'm going to do is I'm going to delete everything that I have here. No, I'm going to delete everything that I have here. I'm going to start afresh. It's going to be blank. But one thing you should do is this, open your terminal. All right, open your terminal or open your terminal. Just make sure you open the folder in your terminal. Install TypeScript, npm I or npm install TypeScript. Okay, TypeScript, but do it globally. If you want to do it for just this folder, no problem. There's no need to do globally. But if you want to use TypeScript everywhere on this your computer, just use the -G option, the G option. So npm I-G npm-g TypeScript. I have already installed it. So I'm not going to install it. So just try and install it if you have not done that. Install it. So if you have done this, TypeScript will be installed. So how do you actually test if TypeScript is installed? Try to do this. TXC. All right, TXC. Check the version of your TXC. And mine is 6.02. Okay, so once you have this TSC version printed out, that means you have TypeScript installed. Okay, so one more thing we can do is that in this folder, you can initialize this folder to be a TypeScript project. All you have to do is TXC hyphen hyphen in it. So we are initializing it to be TypeScript. So it will create this tsconfig.json. Look at it, it has created it. So look at what we have. If I open it, you can see we have couple of configurations here. We have couple of configuration here. Okay, so we are going to come back to take a look at it. So with this, now this is a TypeScript file. All right, so let's continue with our slide. So it helps us in type checking. All right. So if I go on now and say let age number equals to 25, if I declare something like this and later go on to change it to a string, it's going to be a problem. So let's go on. I will create a TypeScript file. Let me call it a main.ts. TypeScript files always end with .ts instead of JS. So if I say let age, all right, if I want to give statically give a type to this age, I will say um, hyphen, I'll give it number. Number is the type, and it is equal to 78. All right. Now, if I go on and now say age is equal to, let's say, whatever we have here. Look at what we are having here. There is an error here. It says type string is not assignable to number. So this is what we mean by type checking. TypeScript is actually checking this, but JavaScript will not. If this was JavaScript, it will never. So this is the reason one, and these are the things that cause bugs, especially runtime bugs, runtime errors. I remember the first application I wrote. I was having a lot of errors because at runtime, when I start running the application, I will just be having errors, and that can actually be a big problem. So this is one thing TypeScript actually help you to solve. Okay, it checks type checking for you. It does type checking for you. So you cannot accidentally or mistakenly do anything like this. It will give an error. Okay, it also prevents bugs before runtime. Imagine we are running this thing as JavaScript. There will be an error here. Okay, and moreover, if you need a book to read on TypeScript, just drop a comment in the comment section or come to the WhatsApp group or the community and ask for a book, or chat me up on WhatsApp, okay? And I will send you a book to read on TypeScript. All right, so it prevents bugs before runtime. Transpilation. Transpilation. We have compilation. Compilation is actually converting source code to machine code. But transpilation is converting a source code from one programming language to another programming language. Do you understand? So with TypeScript, everything is converted to JavaScript. All right. So with TypeScript, if you have something like this, it will be converted to JavaScript. So let's take a look at this transpilation so now if I go on now, if I try to, we'll come back to this configuration files, okay? But if I go on the terminal, if I go on the terminal and say tsc tsc main, all right? If I hit enter, it says the configuration is present but will not be loaded if blah 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 blah. Okay, so now the thing is because we have the configuration file here, it's actually restricting some things for us here because of the configurations we have here. Okay, so is present but will not be loaded if files are specified on command line. Use ignore config to skip this error. Okay, so now let's assume we don't have this error. Let's see whether this is why we are getting this. Okay, still the same thing. So I can go on now and say, okay, let me remove this configuration. I will initialize it back. Let me remove it and then run the script again. All right, it is going to create the JavaScript file for me. You can see it. It has created the JavaScript. So this is the JavaScript file, and this is the JavaScript file, and this is the TypeScript file. This is TypeScript, and this is JavaScript. And you can see there's nothing like any type here. There's nothing like any type. Look at the TypeScript and look at the JavaScript. Just try it yourself. Okay? Try it yourself. You can see what we are doing here. So the reason why it wasn't running because of the configuration. All right. So now we'll come back to configuration later. Okay. So you can see now that it has converted this TypeScript file to JavaScript. All right. And why we are seeing this error is because we are having age in both here and both here. But don't worry, we are going to sort it out when we take a look at the configuration file later on. Okay. So it converts TypeScript to JavaScript. That's transpilation from one language to another language. So TypeScript to JavaScript. Now, it also converts modern JavaScript to older JavaScripts. Now, we might be writing ES6 or a newer version of JavaScript. But the thing is that most browsers might not might not support new modern JavaScript. So TypeScript would also help us and convert it to old JavaScript. But you have to tell TypeScript which JavaScript version do you want it to convert it to. That is what we do in the configuration file. So I will visit the configuration file again. Okay, so when you say this is arrow function is not available in older JavaScript, but we can write it something like this in TypeScript, and TypeScript will convert it depending on our configuration. TypeScript will convert it to the normal JavaScript file. So now, but this is called down leveling. All right. So I am going to let me take this thing back. I'll say txt init. All right. Then if it has generated configuration file for us. One thing I have to do here is this. I'm going to uncomment this root and also uncomment this out directory. Okay. So we are telling TypeScript that all of our files will be in the source folder. So I'm going to create a source folder now, and the generated JavaScript will be in the out directory dist. Okay. Now, if I go on, we are using module. The module we're using is Node Nest. All right. The target is ES Nest. So we are using the Nest JavaScript version. All right. So some people can say ES 5, ES 6, but recently I don't think TypeScript is running at ES 5 because it is deprecated. So there are a couple of things we can do here. All right. So, but just these few ones, I have just have commented out this root directory and out directory. So we're having an error here. If I take my mouse over, you will see that it's saying the file, just read this error message. But basically, what we are doing here is that it said the file is in the program because mark default the file in common.js model because this was not found. Okay, so first of all, I think I should also create a package.json file here. All right, but first of all, let me create the source file, the source folder. If I create the source folder, I'm going to take my main.ts inside of the source folder, and then I will take this JavaScript out. So let me try to run this again. TS main, I don't need to do TS main anymore because everything in the source, because of the configuration I've just done now, TypeScript will look for anything in the source. But what I can do is I can say TSC and watch so that any changes I have on this folder, TSC will watch it for me. So it finds no error, and you can see it has generated the dist. Look at, we said that we told TypeScript to generate all the JavaScript file on in this dist folder, and you can see it created the dist folder, and every of the JavaScript file is here. You can see. Look at what it did here. Do you understand? All right. So there are a couple of things we have here, and then this is the main distance. So with that configuration we have here, we just commented these ones. So we have this now. Do you understand? So if you want to run the JavaScript file, that means this is the one you will run. But TypeScript has actually done something for us, converted the main.ts that we have here to main.js. All right. So this is transpilation that's transpired. Okay. So now, if you have anything, okay, let me go and let me create this arrow function. So if I'll go back to the main.js, so I will say, let's say const add is equal to, so I'm going to use the arrow function. Oh, let me even use async await. All right. These are a couple of async await. I'll do this and I'll say const rest is equal to await fetch. I'll just give a fake API this thing here, so it doesn't matter. All right. So you can see now that the TS is watching. You can see it has just as soon as this thing was saved, it watched the changes and did it for us. So if I come back here, if we go back to the main.js, you can see the new code that we have. You can see what we have here now. Do you understand? All right. So it converted this thing to ES Nest. And that is why we see having the arrow function here. But if you want TypeScript to convert this into ES6, let me change this into target to ES6, ES6, it will run at ES5. All right. So you can see it has changed. The TSC has watched this and it has changed it. If I go back to the main, you can see, look at what we have here. Plenty code. All right. Plenty code. But the thing is that when you're writing in TypeScript, you don't even need to care about the JavaScript. You're sure that it will convert it very well. So you can see we have plenty because of the async await that we are using. It has converted it to something of lower, of older version. All right. So if I go back and change it to ES, if I try to do ES5, it will frown. Okay, look at it. It's giving me an error. It says this is duplicated, so I shouldn't be using ES5. So, but I'll go back to ES next. All right. And if we go back to the main.js, you can see that it has converted everything now. Okay. So depending on the target, you will tell TypeScript where you want to target, where you want it to convert it to. So this is what we call down leveling. Okay. Now, the file controls everything. The configuration file, tsconfig.json, controls everything. That is where you configure how you want TypeScript to behave. All right. Most important options, the compiler option, we have the target. In our case, we are using ES Nest. You can say ES20, whatever. The target means to what version of JavaScript do you want it to convert it to. The module here, we are using ES module, right? Our config says ES module, node nest. Well, because these are the recent Java TypeScript. So our module is node nest. If you want to use common JS, you can do that. That is where your configuration lies. So if you want to use strict, now look at what I'm doing. If I go back to say, I don't want to use, look at the JavaScript that is generated is using strict, use strict. All right. If I go back and say, I don't want that option. I'll scroll down. It says strict to be true. If I comment it out, look at what is going to happen. But this is bad though. This is bad. It is watching it and it has compiled it again. So you can see, okay, still using it anyways. Okay. Okay, so now let me go and change something here. Let's assume I just did something here. It will change and let's see. Okay, it's still using it. Okay, it's just don't even try this. Always use the strict, please. All right, there's no need even showing you any of this. So always use strict. Okay, so we have the root directory. I've just shown you the root directory. We also have the out directory. I've shown you what they mean. Okay, so now strict true, for that option of strict true, is very important. It enables strict not checks. All right, so it's better for type safety. All right, it helps with fewer bugs. All right, it checks for null. All right, so if something is supposed to be it actually checks for we make sure that none of our variables are accidentally given the null value. So it's always on in repo. Just always have it on. Strict true should be always on your configuration file. The target is which version of JavaScript. I have explained this already. ES5 is no longer accepted. It is deprecated. It won't accept ES5 anymore. You can do ES20 or ES Nest. All right. The module can be common JS ES Nest. Use ES Nest, Node Nest for. So look at our own configuration file. This is what TypeScript generated for us. So we'll work with that. The module is Node Nest. All right. The module is Node Nest and the target is ES Nest. Okay. So static typing versus dynamic typing. You know that JavaScript is a dynamic programming language. So it checks types at runtime, and that's why we always have plenty errors. So, but TypeScript checks before running. TypeScript is a statically typed programming language. It checks your variables, the types of your variables. You can see when we try to do something like this, when we said age is equal to this. It gave us an error. So it's statically checking it. And you see, it could not compile because we have an error here. All right. So it's more predictable, fewer runtime errors, but dynamic typing is hard. All right. It checks during execution. So the types of variables, this thing that we are, this error you see that we are having here now, that is actually helping us as developers. All right. It's this is for JavaScript, it will check it at runtime. So it is at runtime that you now know that you made this mistake. So it's better TypeScript gives you this error at compile time. This is called compile time. All right. So it's flexible, but it is risky. Dynamic typing is risky. I don't even try it anymore. So real example. So we have something like this. So look at this function. The function takes A and B, and the function is doing A plus B. All right. And for TypeScript, if this is TypeScript, TypeScript will know. So if I go on now, let me write this function. Let's say I have this function, const. Okay, let me just change this function. Const add. Let me change it. Oh, sorry. All right, so it takes A and B, and then you can see TypeScript is already warning me that I did not give A plus B. Look at what TypeScript is telling me. No, you have to give us the type. Give us the type. But if it is JavaScript, JavaScript will allow you, and you might go on and make that mistake we have in the slide. So for TypeScript, I will not say this is number. All right. This helps my productivity. This kind of errors it won't happen again. You can see everything is perfect now. But if it was JavaScript, this will just go, and then we cannot make that mistake of this. Try and write this thing in JavaScript. Just try and pause the video, try and write this thing in JavaScript and try to run it. You'll see that the error will not come at compile time, the error will come at runtime. All right. So, but this is the better way of writing it in TypeScript. So it has the parameter A has type number, B has type number. So if you try to do this, TypeScript will give you an error. So if I go on now to say add, and I'll say 7 and 90, it won't work. TypeScript will tell me there is an error. You can see it tells me there is an error. So if I want to fix it, it helps me to fix it at runtime. Sorry, at compile time. And you can see everything is fine now. All right. So TypeScript design principles, gradual typing. Okay, you can do something like migrate slowly, let value this. So this will give us the type any. All right, although using any type is bad. So I can say let A this. This is valid. So if I take my mouse over A, you can see that A is of type any. We'll talk about the any type later on. Okay, so TypeScript does something we call inference. It will infer the type of the variable based on the number you gave it. But normally in JavaScript, now this will be type of undefined. But in TypeScript, it is any. We'll talk about that later on. You don't need to type everything at once, okay? Structural typing. TypeScript checks shape, not name. So look at, we have type A is equal to this. This is an object, but this object, the key is actually a string. All right. So A and B have the same structure. Both of them have name properties. So A is equal to B in this case. So let A of type A is equal to this, and let B, all right, is equal to A. So in this case, A and B are equal. So TypeScript uses something we call structural typing. This is why TypeScript is very flexible. As long as they have the same structure, all right, we say it is assignable. So in this case now, A is assignable to B and B is assignable to A because they have the same structure. All right. Type erasure. So all types are removed after compilation. So if you have anything, there's no runtime cost. So if you take a look at the types that we are having here, if you go to the JavaScript, you will not see the type. Look at it. That type is not here. So during compilation, TypeScript removes everything. When it compiles it to JavaScript, to remove everything that has to do with type. All right, it removes it. So why TypeScript is powerful in web projects? API safety. Of course, we are building real projects, so we'll be dealing with APIs. All right, so API safety. So imagine that we are expecting that the API that we are calling is giving us a user object. All right, so we can actually create our own type. We'll talk about this type keyword. All right, so we can create our own type, the user type, and then we can use it. So it prevents back end and front end mismatch. So imagine that somebody a separate a different developer is writing the back end and another developer is writing the front end. They can have a single structure, all right, that both of them can use. So the back end is returning a user with this structure, then the front end will consume the data using the same structure. Don't worry, as you go on, we'll understand this type. Some of you have seen me use this type interface like this, okay? Refactoring confidence. When you want to refactor your code, you will be sure that your code is not going to break, unlike JavaScript. But if you don't understand what refactoring is, it's okay. I wouldn't be explaining that here. So when you rename things, rename things across your project, they will be safe. IDE superpowers, all right, autocomplete, IntelliSense, error hints. These are when you're using TypeScript in your project, these are the things your IDEs. It helps your IDEs to give you some superpowers. Scalability, let us become more manageable. It's easier to manage TypeScript code than JavaScript code. So the mental model you need to have is how to think in TypeScript. Instead of let me write code and debug later. No, use TypeScript and think like design the data structure, then enforce rules, then write your logic. All right. Design the data structure, enforce the rules, and then write your logic. All right. So example is this is the bad approach. Let user equal to empty object. This is a bad approach. You can create a user type that has ID and name. So this is better. We have created the data structure and then you enforce rules. All right. So real world analogy, think of TypeScript like a security guard at the gate. JavaScript lets everything in. But TypeScript, when we are writing with TypeScript, we have a bouncer. We have a security guard. All right. TypeScript checks everything first before allowing anything. So in summary, TypeScript is a superset of JavaScript. Okay. And then a static type system, a compile time safety layer. It is created by Microsoft. All right. So let's take a look at JavaScript versus TypeScript. TypeScript JavaScript has dynamic typing. You already know this. This is allowed in JavaScript, but in TypeScript it is not allowed. All right, it's not allowed. So JavaScript checks errors at runtime, while TypeScript checks errors at compile time. So the TypeScript compilation pipeline, TypeScript doesn't run directly. It goes through a process. Your TS file will be compiled or transpiled, but we mostly use the word compile. So your TS file will be compiled by the TypeScript compiler. It will transpile it to JS files, and then the JS file will now be run either on Node.js or on the browser. So two important processes, TypeScript always do type checking. It ensures correctness, removes invalid operations. Transpilation, it converts TS to JS. Of course, we are not running TypeScript, although we have TSX that we use to run TypeScript files. All right. Some of in my Express.js, my backend applications, I use TSX to run my application. All right. So it removes all types. When it is transpiling from TypeScript to JavaScript to remove all types, then the important truth is that types do not exist at runtime. Types only exist at compile time, that time you're developing your application. It doesn't exist at production. So let us take a look at some type system fundamentals. All right. What is a type? You already know JavaScript has some primitive data types and also some custom data types. The primitive data types, we have the Boolean, number, string, null, undefined. Do you understand? The arrays, name them. So a type is a set of possible values. Example, string, hello, world. So these are sets of possible values, number, one, two, three. So success can only be true or false. All right. And they're only that exact value. So these are set of possible values. So you're saying that, oh, this is a type and this type has set of possible values. There are if the value that you're trying to give that type does not exist in the set of the possible values for that type, TypeScript will flag it as an error. Okay, so types categories, we have the primitive types. You all know all these. You already know all these things. So we also have the structural types. This is an object, but in our case now, our objects have some types. Do you understand? If I want to create this user object now, okay, this is a type. This is a type. Normally, if I want to create a user object in JavaScript, I will go on and do something like this. Okay, this is my TypeScript. I will go on and do something like this. I will say let user equal to this. I will now say name. All right. I will now say name is John. All right. Blah blah blah. But if it is, of course, it is valid. This is valid, but TypeScript is going to infer. If I take my mouse over, you can see that it's giving me, look at the structure. All right. But I can still say, okay, I want this user to have the type. So if I want to include the type, I will say colon, then I will say this user will have name, and this name is going to have a string value, and I can say age, and this name age will have a number value. And you can see now we are having an error already. If I take my mouse over to this user, it says that the property age is missing. So look at the value I gave. So in this case now, TypeScript is saying that this user is a type and this is the type of the user. So it has a set of possible values, but I am trying to assign something that is not in the set of that, in that spectrum of the possible values for this user. So if I want to correct this thing, now you can see these are the simple small errors that we actually face at runtime. I cannot say age because it's even giving me IntelliSense. It's giving me IntelliSense. I cannot say 90 and everything's okay. Nobody's frowning anymore. But if I still want to make this thing make more sense, I can create a type. I'll take this thing out and I'll create a type. I will call it user is equal to this. And then I will now use that type. I'll say this user is of type user and we are good. Do you understand? Don't worry, we'll learn more about this I didn't just learn all these things and get good at them just one lecture or one tutorial or one day. No. So if I go back to the main.js, you will see now that we created a user type and look at all those types that we created was not here. Remember, we said during transpilation, we don't include types. So you can see in the main.js, we are having the type. Though this typing helps us as programmers during development. But during compilation, we don't get them here in the JavaScript file. All right. So we have advanced types like union. We'll talk more about all these things as we go on. Intersection, generics, utility types. Okay. We also have any versus unknown. Any, when you want to write a variable and you're not sure of the data type of that variable, you can use any. But when you're using any, it's like you're falling back to JavaScript. It's dangerous. I think I made this mistake a lot, even till now. But I think after this class, I'm going to repent and I'll stop using any. All right. So when you say let value, no, this is like you're writing JavaScript. Don't use the type any. All right. Instead, because look at now, we are trying to say value.uppercase. It is allowed because we passed in a user. But when we try to do something like this, it's not allowed. So please don't use any unless the extreme case. You don't know what else to do. You can do any. So this turns off JavaScript safety. With this, now there's no safety. Why this error will happen here is that because there's no type safety here. So don't use any, because when you use any, you're saying that it can contain anything and it can cause errors. Instead, use the unknown. Instead of saying any, use unknown. But one thing with unknown is that you cannot perform operations on unknown because TypeScript does not know the type. So let's go on now. Let's say now, instead of me saying um let age equal to any, all right, let age equal to any, I can go on and say any age. I can do age. I can do age plus plus is valid. Do you understand? But what if I try to say age dot uppercase or age dot to upper? Okay, that will be an error. Okay, so if I go on to run this code now, there will be an error because age, which is a number in this case, does not have anything called to uppercase. Do you understand? So, but if I'm not going to, okay, let me run this main.js file now. Let's see. You can see we got an error. It says this, look at it. So these are the kind of errors you'll be having if you're using any. But instead of to use any, all right, use, now the thing is that I have mistakenly used the upper, this is supposed to, the uppercase function is supposed to be used on a string. But because of it's just a mistake. I didn't even know, and I use this. So, but this can cause runtime errors. Do you understand? So, but if you want to use any, instead of using any, use unknown. But as soon as I use unknown, you can see it has flagged it because we cannot perform operations on unknown. This is safer. So before I can perform any of this operation, I can do something like this. I can say, let me use a ternary operator. I'll say type of, if I say type of age equal to number, then, oh, sorry, then I can use, you can see there's no error again now because what I have done here is that I have narrowed it. It's called type narrowing. Okay, sorry, this might be sounding so strange to you, but I have some book that can also help you. And short, as you go on, you get to understand more. So I will not say if this one is a string, you can see there is no error now. But what I was doing here is I'm conditionally checking. Before I will use this uppercase, I'm conditionally checking. So if I go on to main.js and run this code again, there will be no error again. So instead of using any, use unknown. But the disadvantage of using unknown is that you cannot perform operations on unknown, which is good. Do you understand? So, but if you want now to perform, you will not be sure. It is not going to be like a mistake that the other way I did it before. In this case, now I am intentional about what I'm doing here. All right, you can say I'm very, very intentional about what I'm doing here. So I'm first of all checking the type of the variable. Okay. All right, so that's it. Use unknown instead is safer, but make sure you check the type before. Sure, TypeScript will even force you to do this because it will flag it as an error. Okay. So you don't care about safety. If you don't care about safety, use any, but it's bad. Short, always use unknown. Instead of using any, use unknown. Yes, it will help you, it will make you to write extra code, but that extra code will help you at production or at runtime. So type inference, how does it work? So when you say let a equal to when you have a variable, look in this case now, this is my type. When I say let age equal to this, you can see I did not specify any. I did not specify any. What's it called again? I did not specify any data type, but TypeScript does what we call inference. It will infer because of the value that I have given I have assigned to this variable, it has inferred that it's a number, and that is why I'm now having an error here. Do you understand? You can see how TypeScript helps us. Normally, this error now, you will see it at runtime, which is very bad. So I will just maybe comment this out. You can see, and it really helps us. So inference, TypeScript guesses the type automatically. In this case now, this is a string. So TypeScript will say that, oh, the message, the data type is a string. How it works internally, TypeScript will look at the value that you are assigning to that variable and then assign that data type of that value to it. Okay? So let s equals to 10, let y equals to, you can see these are their data types. So it will infer let value. In this case now, when you do this, value will not be a number. All right, there will be an error here because you have given it 10 before and TypeScript has inferred that it's 10. Okay, type becomes any. When you do this, type becomes any, but this is bad actually. All right. That is why you don't have to use any. So we have arrays. You already know what arrays are. We used to store values of the same type. But in JavaScript, you can store different values, which is bad. But in TypeScript, you cannot store of different types. It has to be of the same type. So this is how you write it. Let nums, then colon, number, this square bracket. Or you can do this. So if you want to declare an array in TypeScript, so if I go on now and say, let nums, I will now say number like this. So this is an array. This is an array of number. So if I go on to say, look at what I'm doing now. You see, look at it. It's flagging it as an error. It says string is not assignable to number because we have said that the data type of this array we're only going to take numbers. P is not a number, it's a string, so it won't work. All right. So if I go on to say 8, 9, that's fine. Another way of doing this is also say let num equal to, sorry, let num, then I'll say array. This is generic. We'll talk about generics later on. Oh, sorry. So this is generics. So I can go on now. This norms. Okay, let me use names. This names is of type string. You can only take strings. If I try to add number, you can see it's string or error. But I can say Paul here. Okay, so this is one way of doing it, and this is another way of doing it. All right. If I try to push 4 to nums, which is number, it will go where. But if I try to push a string into it, it will flag this as an error. You can see this is very, very good. Mixed arrays is not recommended, but you can still use mixed arrays. So you can say that the data type is either string or number. So that's something we call union type. We'll talk about it later on. So if I want to say, it's not recommended actually, but in case, I can just say, give me a string or use the pipe symbol like this. So you can take, in this case now, you can take strings and numbers, but let this not be something you are used to. This is not good. All right. But if there's any reason for using it, no, it's very, very possible. This is called union type, the pipe. So we are saying that this array can take in string or number. All right. So we also have something we call tuples. So if you want to have a fixed array, a fixed structure, all right, you can use the tuple. It's a fixed length array with fixed types. So if I give this structure now, it means that I can only have 2 items. The first item must be a string, the second item must be a number. So if I go on and do something like this, let's go. So let me say, I already have user B. Let me take this guy out. Let me take everything. If I say person is equal to, so the type is what? I will say string and then number. So I go on and say is equal to, I'll go on and say is equal to John and 89. You can see, if I try to add another thing, if I try to add true, it will flag it as an error because that's not the order, that's not the structure that I have. So look at it very well. It says, if I take my mouse over, it says person is declared but not used, but it says string number boolean is not assignable to string number. So we are giving a strict structure, fixed. All right. It's not even because of the boolean we are using. If I try to do another 67, it will still give us that problem because we only have string and number. We did not have string number, but we are doing string number here. But if you want to fix it, you can come and say, okay, the third one will be number. And we are good. And if you try to now say number first before string, there will be a problem. Look at it. It's a problem. What is it saying? Number is not assignable to string, but it's expecting that the first item here should be a string. So this tuple gives, if you want to have an array that have a structure, fixed structure that cannot be, you will use tuple like this. So this is something you can also read on to learn more about. So why tuples matter? They enforce order, they enforce length, they enforce type consistency. You have seen me trying to change all those things, and you can see that I have some errors. So problem with that tuple, you can see now that here we have Paul and 25. They are string or number. Do you understand? But there's no strict structure here. Anybody can put anything here. So if you want to have strict structure, order, consistency, type consistency, you use tuples. So we also have the object types. Of course, you have seen me do this already. The only difference is that we give it a type. We say that this user has a type, and the type is name and age. It must have these two properties. So if you're assigning any value to it, it must have. You've seen me do it already before. So structural typing, TypeScript checks shape, not name. Type A that has this structure is the same thing as type B that have this structure, all right? And this is allowed. This is called structural typing. It's allowed. Union types, okay? A variable can hold multiple types. Let ID, string or number. So we are saying that this ID can either be string or number. If you even want to add string or number or Boolean, you can use another pipe. You have seen me use it already. So sometimes our variables can have multiple, we are expecting it to have multiple types. But the thing is that when you're not making use of them, you have to check them. You have to use the type of to check. Okay, but in some areas this is good. In some areas not good. Especially this is not the best example. Maybe if you want to check the status of message, yes, you can say the status can be success, sent, read, or whatever it is. But ID should be ID. And when you're doing something, like make sure you're checking the type before you perform any operation on them. So if I now say ID to uppercase, look at what we have here. Console.log ID. So if I go on now and say ID to uppercase, and meanwhile the ID they gave me what? Because now this print ID can take in either a string or a number. So imagine that the user of my application is now giving me a number, and number is not the uppercase to uppercase method is not available on numbers. All right. So because TIA doesn't know which type, so you have to check. All right. Use the type of before you perform any operation on the union type. Make sure that you're sure of the type, just like the unknown. All right, make sure you have, or even in the any, make sure that you are sure of the data type before you can perform any operation. So we also have literal types. You can say that I can do this. Let me shock you now. I can do this. I can say let age. I can say age is of type 78. This is called literal type. Look at what is going to happen. If I try to assign anything that is not 78 to it, it will be an error. So this is called literal type. All right. So it means that you're only giving it can only be 78. So this is called literal type. So you can also, in this case, now we have let status equal to success or error. So this is, we are using literal types, but in union. All right. It can be success or it can be error. So it only accepts those values. This status can only accept success or error as the value. So in fintech, you can have transactions to be pending, success, or failed. Do you understand? So as we go on, we'll be learning more. Type errors, all right? You can't do this. You can't do this. Hello is not a number, all right? It prevents runtime crashes. It prevents production bugs and data corruption, okay? Type versus value. Let age of number to be 25. So number here is a type. but 25 is a value. Do you understand? The number here is the type of age, and 25 is the value we are assigning to age. Types exist only during development. This type only exists during development, but once it is compiled or transpiled to JavaScript, the type will no longer be available. Okay? All right. So let's take a look at this example. All right, this might be somehow, but we'll talk more about how to create custom types. So here, you have seen me do some of these things. You guys have seen me do some of these things already. So I'm creating a wallet type. All right, so I'm creating a wallet type, and you can see here we are using the union type, and we are using the literal type. We're using literal type here and the union type, and this is the normal type that we have, but this is a custom type. So use the type keyword. Don't worry, we'll talk about that in later classes. So if I don't provide all this in this assignment, that will be to flag as an error. All right. So transaction here is the same thing we can create, but don't worry, as we go on, especially when we start building our applications, you will see me use a lot of this. So ask me for the book that can help you understand TypeScript very well. I'll send you the PDF, okay? All right. So think in types before writing your code. Ask, what is the shape of my data? Avoid weak typing. Don't use any. Instead, use unknown. And then check for the narrow your variable. All right. Prefer inference when clear. All right. So this is clear. You can prefer inheritance. All right. So inference, you can prefer inference when it is very clear. So this is very clear because the data type here is a string. All right. Overusing any, a case type, but why should we use any? If you're still using any, overusing any, that means you're still using JavaScript. Ignoring errors. TS errors are your best friends. Embrace them. They are helping you. Always use the strict mode. Always enable strict to be true. Missing types carelessly. Don't do this. When you do this, it can take any. So don't do this. Don't be lazy. Create your types. All right. Thank you very much. If you have any question, please drop in the comment section. And if you come to the WhatsApp group, come to the community and let's discuss it. Thank you very much, and I'll see you in the next class.